Hello, welcome to Prepclass Tutors. I am Abel Godwin and I will be your math tutor. And we are going to be concentrating on WAEC mathematics past questions for the year 2020. So journey with me along this video. And don't forget, like and comment on our videos. Like and comment on our videos on YouTube because this will give us the moral support to keep us moving. Okay, without much delay, I would like us to look at question 36 to 40 in this video. So, question number 36. It says, in the diagram, O is the center of the cycle, SOQ is the diameter, and S angle at RP is equivalent to 37 degrees. Then the question says, find P angle at SQ. So this is it. S angle at RP is 37. Now we're asked to find P angle at SQ. So we are just looking for this angle here. Now, if you are conversant with a cycle theorem, you discover that once you just know this theorem, you can practically find your way out of these things by just remembering them. So you can imagine you were being asked to find angle at Q here, that's S angle at QP. This, you remember that it's just a matter of matching angle in the same segment. But no, that's not the case in this particular situation because we are required to find this portion. And you can't actually specifically point your finger on an alternate segment to this. They don't even have same segment at all using this part. So what we need to do here is to apply some basic principles here about the sum of angle in a triangle. Now, because this is the diameter of the cycle, so we can say that since the hypotenuse makes this diameter, then here must be angle 90. Yes, because if your hypotenuse is the side, if your hypotenuse is same as your diameter, then it obviously means that the angle at this circumference is 90 degrees. So if here is 90, and remember, angle in the same segment, you can see, because this is major segment, and this is minor segment, this portion, minor segment, because this chord divides the cycle into two. So at this point, this angle here is same thing as this. So now we are looking for this angle just from here to here, angle at S. So angle at S, angle at Q, angle at P, the sum must be 180 degrees. So angle at S is unknown, angle at Q is 37, angle at P is 90. By the time we add this, we have 127 degrees. And by the time you cross multiply, you discover that your angle at S is 180 minus 127, which is 53 degrees. So this is option C. Moving on to the next question, question number 37 says, find the sum of the interior angles of a pentagon. Now, this is basically a formula work, and you remember this, that the sum of interior angles of a regular polygon is given by 2n minus 4, everything close brackets, open and close bracket, times 90, or open bracket n minus 2, close bracket, times 180. So it's either use this or use this formula. They both work, but I choose to use this for conveniency, and let's just say it looks a bit tidier for me because the value is not that cumbersome to bring about intimidation in your calculation here. So we were told that this is a regular pentagon, so the number of sides, this n signifies the number of sides, which is 5 for a pentagon. So the sum is going to give us 2 times 5 minus 4 times 90. So this is same thing as 10 minus 4 all times 90. So 10 minus 4 is 6. 6 times 90 is 540 degrees. And that is option C. So question 38, it says, the diameter of a sphere is 12 centimeter. Calculate correct to the nearest centimeter cube the volume of the sphere. Now take your pi as 22 all over 7. The diameter of a sphere has a diameter of 12. The diameter of the sphere is 12 centimeter, and volume of a sphere is given as 4 all over 3 pi r cube. Remember that your radius is actually half of a diameter, so it means that the radius will be 12 all over 2, which is 6 centimeter. And basically, the volume is just a matter of substitution. 4 all over 3 times 22 all over 7 for your pi times 6 raised to the power of 3. So you discover that by multiplying this, you'll get 905.14, which is approximately 905 centimeter cube. Don't forget the radius actually has a unit in centimeter and not in square, so this should be neglected. So this is the volume of our sphere, and this is reflected in option C. Moving up to the next question. It says a box contains 12 identical balls, of which 5 are red, 4 blue, and the rest are green. So they said, if a ball is selected at random from the box, what is the probability that it is green? The probability that the ball will be green. So if you look at what we have, probability is defined as required outcome, the ratio of that required outcome to total outcome. So total number of balls were given as 12. The red balls, there were 5. Blue, there were 4. And green balls, we have to sum the red and the blue balls to get 9 and deduct that 9 from the total to give us what? Green balls, because there are just 3 types of colors there. So if a ball is picked at random, the probability that it will be a green will be 3 all over 12, which is 1 all over 4. So this is our answer, and that's option D. So going to the last question in this video, and it says a box contains 12 identical balls, of which 5 are red, 4 blue, and the rest are green. If 2 balls are selected at random, one after the other, with replacements, what is the probability that both are red? You need to be very careful here because it looks like a repetition of the previous question, but no, it is not. Rather, this question is testing you on slightly different concepts. So let's look at how to proceed with this. Now, remember, probability, as we said earlier, is required outcome all over total outcome. We know that our total balls 12, red balls 5, blue balls 4, giving us green to be 12 minus 9, which is a summation of 5 and 4, and that will result in the number of green balls being 3. So the probability of picking 2 balls one after another with replacement, such that when you remove one ball, you return it and still remove it again. So we want to find out in either situation, red balls are coming out, 2 red balls. So in the first instance, there are 5 balls, don't forget 5 red balls, so 5 all over total, which is 12. And by the time we would have returned that ball for a second pick, that will give us 5 all over 12 again. So that is why you now see the use of this multiplication. Remember your multiplication rule in probability, the AND rule. So we're still using this because for the first pick and for the second pick. So 5 times 5 is 25. 12 times 12 is 144. And this is option A. So with this, we have come to the end of our video. And please don't forget, like and comment on our videos. Yes, until then, do have a nice time.